Hello, my name is Raymond, and welcome to Phase 2's Advanced Feature Testing. I'll be giving you a brief overview of unit testing, automated acceptance testing, brief overview of why we do testing, and how it helps. So an overview of unit testing and automated acceptance testing. Unit tests are automated tests we write to test our project. So our test code will input some data into our classes and/or methods and compare their outputs to what we expect them to return. We usually write unit tests on individual units of software, so individual methods and classes. If you have large chunks of code, you may need to refactor it into smaller functions and methods. Next is automated acceptance testing. This automates what a user would normally do when they're manually testing. So say a login feature and a logout feature. The person would have to open a browser, go to the website, find the login fields, enter their username and passwords, log in, check that they've logged in, and then log out. Well, we can test this feature pretty quickly manually. Anytime we change our backend, frontend, and database, we will need to check that this feature still works. And instead of doing it manually, we can automate this so that anytime we change the code, it will run. It gives us some peace of mind when we change our processes or change our code that the workflow still functions. We can also write our automated test in a completely different language from our base project. However, it's a good idea to keep it at least the same to allow maintainability across the team. So why do we do testing? It allows us to catch bugs and errors early on, catch unintended changes made to code. This ensures that we can maintain our code and ensures that our code is of high quality. It also provides some documentation on what we expect to be inputted into our methods and functions, and also what we expect to be outputted from them. It also allows us to do some regression testing. So as our codebase grows, we can check all the pieces of code still work as we expect. Now it's time for an example. Let's say you have a function that takes in a person's age, and it returns whether the person is a child, adult, or senior, and that we have implemented our if checks as shown in this table. Do you see any problems in this implementation that I've done? One obvious problem is that our conditionals overlap. Also, another problem is that age can be a negative value and still return child. Although less of a problem, senior doesn't have an upper boundary. All the things that I've mentioned are things that we would test in our unit test. Before you check those edge cases, it's a good idea to check the obvious first. And in our case, check if your function returns child, adult, and senior with the corresponding ages. I would implement these tests as 3 separate tests, but you can also do it as one singular test. Next, we want to test our edge cases. So one unit test for entering a negative value, another test to check our conditional boundaries, so say the age is 18. Additionally, you probably want to handle ages over a certain point. The example I've given here is quite simple, but the principles still apply to more complex pieces of code. While the example I've given here is mainly to do with unit testing, all the same principles apply to automated acceptance tests. Next, I will show you an example unit test project. Before we can start, we need to add an extension. Go to Extensions, Manage Extensions, and make sure that NUnit Test Adapter 3 has been installed. If this hasn't been installed, go to Online and search for NUnit. And make sure NUnit 3 Test Adapter has been installed. You should be able to see a download button. Click that to install. You will need to close Visual Studio 2019 for it to install. Once the install is finished, open the base project. Right-click the solution and add New Project. Search for NUnit Test Project. Click Next and give it a name. The test project usually has the same name as the base project, except we identify it with the suffix .test. Create the project. Go ahead and delete the default unit test file that was created with the project. Now we need to add our base project as a reference to our test project. Right-click the project and click Add Project Reference. Select Student Sims and click OK. Now we need to add our NuGet packages. Go to Tools, NuGet Package Manager, and then search for mock, M-O-Q. Select it and install it to our test project. Next, search for NUnit. Creating an NUnit project should already install this package for you. Once all the packages are installed, we can start creating our unit test. Right-click on our project and click Add a New Item. Give our unit test the name. In our case, it'll be Country Identifiers Unit Test. Before we start our unit test, let's take a quick look at the code that we're testing. The Country Identifiers repository does basic CRUD operations on our database. Let's go back to our unit test and copy and paste the code snippet from GitHub. Some errors will start popping out because we haven't imported any of our packages. Hover over the errors and resolve them. So let's take a look at what we're testing. Get all countries. If you take a look at the function, it calls our database and retrieves all records from that table. Let's go back to our unit test. Here we're creating some dummy data and making it queryable. Next, we're using mock to mock our DB set. We are also setting up our DB set to return our mock data. We're doing this because we want to remove the dependency of having to access our database. Next, we are mocking our student context and making it so whenever country identifiers table gets called, it returns our mocked DB set instead. Next, we initialize our class and then call our method, get all countries. If we go to the implementation, we can see it has to access our database. Next, we have our asserts. We're checking our expected output with the actual output from our function. Our first assert is checking if the correct amount of records was returned. The second assertion is checking if the first record returned is correct. This is also the same for the last assert. Now that we have our unit test, let's run it. And our test has passed. Let's check if our unit test actually works. We'll change the expected result from one of the asserts. Run the test again. And our test has failed. So as you can see, the result returned was AU, but we expected NZ. Let's change our test back to the original and rerun it. Let's create a new unit test. Click Add, New Item. Call it Student Controllers Unit Test. Copy and paste the code snippet from GitHub. And correct all the errors that pop up. Like the last unit test, we're setting up some mock data. Here we're using the student model to mock our data. Next, we're mocking our country identifiers repository. This is because we're using two of the functions in this class. Instead of using the country identifier repository directly, I'm going to use the interface. The interface just contains the methods that should be implemented in country identifiers repository. Next, we're setting it up so when these two functions get called, it returns our mock data instead. In this case, getStudentById will return the student that we set up. And the same for getCountryExtension. If we go to the repository, we can see the implementation of these two functions. These aren't the function that we're unit testing, so we don't really care about the implementation. Instead, the method that we're interested in unit testing is getStudentPhoneNumber with extension. If we go to our controller and scroll down, we can see our method calls getStudentById and getCountry's extension. Next, our asserts are checking the results from our controller. We're checking if the result wasn't null, which means there's a student that exists in our database. Next, we're checking our expected result is the same as the result from our method. Go ahead and run our test. Awesome, it's passed. Let's change our expected result to see if it failed. Cool, now we know that our test is working. This concludes the unit testing portion of this tutorial. Next, I will show you how to do automated acceptance test using SpecFlow. Before we can start, we need to add an extension to Visual Studio. Search for SpecFlow. This will add all the templates for SpecFlow to allow us to do the acceptance test. You will need to restart Visual Studio. Once the restart has completed, create a new project. Search for SpecFlow and select it. Give it a name. And click Create. Make sure .NET Core 3.1 is selected and the test runner is NUnit. Go ahead and delete the default files that were created with this project. Next, in the Features folder, add a new item. In the SpecFlow tab, select SpecFlow feature file. name it login. Copy the code snippet from GitHub. In the finished example project, the password is redacted. Simply create a new Reddit account if you wish to run the example project. Right-click the feature file and select Generate Step Definitions. A small window will pop up. Click Generate. Save this file to the Steps folder. This will generate the methods that will be used in our acceptance test. If your feature file doesn't change color, it means Visual Studio hasn't made the connection with your feature file and your step definition. You will have to rebuild the solution If this doesn't fix the issue, you might just need to refresh the screen. Go to a different file and then go back. And now it's time to add some NuGet packages. Search for Selenium. And install the WebDriver and the Chrome driver. Next, search for SpecFlow. This should be pre-installed when we created the project. Be sure that SpecFlow has been installed. SpecFlow.NUnit, SpecFlow.tools.msbuild.generations have been installed. We also need to add specflow.assist.dynamic into the project as well. Add a new folder to the project. Call it Pages. And add a new item to the folder. Call it Front Page. Copy and paste the code snippet from GitHub. And correct all the errors that pop up. And then go back to login steps. Copy and paste the code snippet from GitHub. And then correct all the errors that show up. Try running the project. You might get an error like this. Open up NuGet Package Manager. Look for Selenium WebDriver, Chrome driver. Select the version that matches your Chrome version. We are now ready to run our test. Right-click the project and click Run Test. we have successfully automated our login process. And that concludes the automated acceptance test guide. Check out the README on our GitHub. It will have everything that I've shown you in this video. I've also explained the code that I've used in this README. I hope this guide was useful, and good luck for Phase 2.